again I am drawing the number line, and this is 0, 1, 2, 3, 4, 1, 2, 3, 4 positive numbers, and -1, -2, -3, -4 the negative numbers. Now suppose that there is a ball which is placed at x is equal to -2 meter. The ball B is placed at x is equal to -2 meter, and from -2 meter it moves to x is equal to -4 meter. So B dash is the final position of the ball. Okay. Now what is the displacement of ball B? Now here the initial position of the ball is equal to -2 meter, and the final position of the ball is equal to -4 meter. So the change in position delta x will be equal to xf minus xi, which is equal to -4 minus -2. Okay, xf is -4 minus xi is -2. So this is equal to -4 plus 2, which is equal to -2 meter. So here in this situation, the change in position of the ball is equal to -2 meter. Now here the displacement is negative, and in our previous example we have found that the displacement was positive. Okay. Now let us consider another situation. So let us again draw our number line. 0, 1, 2, 3 and 4 and 5. We have -1, -2, -3, -4 and so on. Now suppose there is a ball which is placed at x is equal to 1 meter, and this ball C is moved from x is equal to 1 to x is equal to 5. Okay, from 1 to 5. So position C dash. So here the initial position of the ball is 1 meter, and the final position of the ball is equal to +5 meter. So what is the change in position of the ball? The change in position of the ball is xf minus xi, which is equal to 5 minus 1, which is equal to +4 meter. So in this case, the displacement is found to be equal to +4 meter, which is a positive displacement. Now suppose I just do some changes in this question. So instead of moving the ball from 1 to 5, suppose I move this ball, say like from 5 to 1. Suppose that initially the ball is placed at 5 meters. So this is the initial position of the ball. The ball, suppose ball D is placed at x is equal to 5 meter, and then it moves from 5 meter to 1 meter. So D dash is the new position of the ball. So in this situation, the initial position of the ball is equal to +5 meter, while the final position of the ball is equal to +1 meter. So what is the change in position of the ball? The change in position of the ball will be equal to xf minus xi, which is equal to 1 minus 5, and 1 minus 5 will give you -4 meter. So in this situation, the change in position of the ball is equal to -4 meter. Okay. Now here you can see that the ball is on the right side of the origin, but still its displacement is negative, because the ball is moving in the leftward direction. See, we have to remember one thing, that displacement is positive when the ball moves in the rightward direction. Okay, when the ball moves in the rightward direction, it may be present on the right side of the origin, or it may be present on the left side of the origin, but it has to move in the rightward direction. For example, suppose I am considering another ball which is placed at x is equal to -3 meter. Okay, suppose there is a ball E which is placed at x is equal to -3 meter, and from -3 meter it goes to -1 meter, position E dash. So in this situation, what will be the displacement of the ball? Now displacement of the ball will be equal to xf minus xi. What is the final position of the ball? Finally the ball is at x is equal to -1 meter. So delta x will be equal to -1 minus initial position of the ball is -3. So -1 minus -3 will give you -1 plus 3. That will give you +2 meter. So here the displacement delta x, which is equal to +2 meter, which is a positive displacement. So this clearly shows that even if the ball is on the left side of the origin, but still it is moving in the rightward direction. Since the ball is moving in the rightward direction, the displacement is taken as positive. And when the ball moves in the left side of the, towards left side, it may be present on the right hand side of the origin, or it may be present on the left side of the origin. But since it is moving in the leftward direction, so the displacement will be taken negative. Okay, so displacement can be positive and it can be negative also. Now we consider a third situation. Now suppose that there is a situation that this is our number line and the ball is present at x is equal to 0. It goes from 0 to 5 and then comes back from 5 to 0. Ball goes from 0 to 5 and then comes back from 5 to 0. So in that situation, what is the initial position of the ball? 0 meter. What is the final position of the ball? 0 meter, because it has finally returned to 0. So the change in position, the displacement of the ball, which is change in position, is equal to final position minus initial position. That will give you 0 minus 0. That gives you 0 meter. So the displacement of the ball in this situation is 0. Okay, so the displacement, if the body or a particle after moving, if it returns back to its initial point, then the displacement will be equal to 0. Now that we have to understand. Okay.